Good, because this is exactly what this session is about. I'm Peter, so I'm from Instana. Instana is a monitoring solution. We position ourselves as an APM solution, so application performance management solution. But I found out, as originally not being from this area, that a lot of people are confused with this term APM. This is why I prefer saying we are doing full stack monitoring. So what we're doing is, on the one hand, distributed tracing automatically. And on the other hand, we are doing infrastructure monitoring. Because in the past, you could focus on this tracing and focusing on an application, and you could see this decoupled from, oh, this looks much better. You could see this decoupled from your infrastructure, but now, especially in the time of orchestration, this is not so easy to separate this anymore. So, let me just show you a short example. I'm logged into DevOpsConf-demo.instana.io. This is one of our software as a service environment. And for those of you who have already visited our booth out there with our partner Proto Security, thank you very much for having us. You could see this environment. And now a lot of you are probably curious, how can I bring my machines into monitoring of Instana? And so to add a new component to this Kubernetes, to this Instana instance, let me just open a terminal. It's pretty easy. So here's my terminal. Hopefully you can see this. Then I have kube. I am connected to a Kubernetes cluster already. So kubectl get all namespaces. And here I get a list of everything that is deployed in my cluster. Before I had to restart my machine, I had the screen open where you could see where this is deployed. This is running in GKE, so Google Kubernetes Engine. It's really easy to deploy this. And this is what's running on this cluster. For those of you who want to, play a little bit around with microservice and orchestration and so on, most of you probably have the challenge, what application can I deploy to this? And because we at Instana, all of us had the same problem, and our team didn't want us to reinvent the wheel all the time, there is something that we call the robot shop. So when you go to GitHub, github.com/instana/robot shop, you will see a project here. And this project has been deployed on Kubernetes. So here you have all the different orchestrators. And what you can do, you can just use this to spin up a microservice application containing all of these technologies on a Kubernetes cluster. And in this case, it's just like this one. So you create the namespace, and then you apply these descriptors folder, and this will automatically spin up all the instances. And this is exactly what I have done here on this machine. So we have a cluster, a GKE default cluster, having all these daemon sets for Fluentd, for Prometheus, and so on. And we have here applications deployed. And in this case, the applications here are the robot shops, the robot shop components like catalog, card service, and so on. So this is now kubectl. Now I want to have an insight what's really going on in this cluster. So let me just open Atom for a moment. And let's go back to Instana. And in Instana here, you have these 3 dots that point you to more. So more. Then you have the management portal. Then you have install agent. And here you have a variety of versions how you can deploy Instana. Manual, you can just download an agent, extract it and start it. This, once you download this, is already pre-configured for your environment. No need to configure anything. You get a tar.gzip or zip file, and this is pre-configured. This is a one-liner that contains all the information. This is a Docker-based container. And here for Kubernetes, we're using Helm, so the easiest way to deploy this. What you can do, you just reuse this Helm chart, and we just specify a Kubernetes cluster. Let's call this DevOpsConf. So, and the only thing that I need to do is I take this, I'm connected to my Kubernetes cluster here, I paste it, and that's it. what happens now is we execute this Helm chart. We fill it in with all the details. So your agent key that it makes you identify as a customer of Instana. You probably saw the endpoint, so it's our European SaaS backend. And what happens now, all the agents are deployed. As it is deployed as a daemon set, when you start a new worker node, Kubernetes will automatically take care that on this worker node, an Instana agent will be deployed. So we can take a look at the logs to see, okay, what's going on. And there you see, this is all the log output, and you can see Instana agent installed and already started. And this is a 3-node Kubernetes cluster. This is all you need to do. So what happens now is I can go, let's go to the last 10 minutes to the live view. This takes a short moment, and then the Instana agents will show up here, and we will have a new cluster. So this works in OpenShift as well. For OpenShift, those of you who are using OpenShift, we have an OpenShift operator for this as well. So it's even easier to deploy this. For those who are using Google Container Engine or Kubernetes Engine, we are in the store of this. So you can just click this, and then it's automatically deployed. So it's super easy. As I mentioned earlier, this is one of our software as a service environments. We started as software as a service only, but we found out a lot of people do not really like this cloud idea, and they want to have this in their own data centers. I'm from Germany, so there's true the same. So they want to have this in their data centers. This is why we have both options. The same software can be installed on premises as well. And here you already see the zone DevOpsConf. This is just what I've specified. And you see here the machines popping up. And this is my Kubernetes cluster with all these components set up. And this is really GKE, standard, robot shop deployed. That's it. Super easy. And here we have our 3 nodes. So what happens now is Instana is automatically knowing all of these machines, is detecting all these components running on these machines, is collecting metrics about these components, and in addition to this is attaching to runtimes, which means in case of Java, for example, we use bytecode instrumentation to trace all the inbound and outbound calls. And what we can do is, on the left-hand side of Instana, you have 3 main sections: infrastructure, what you're seeing here, this is the infrastructure map, Kubernetes, that we will cover in a moment, and applications. And when you click on applications, you have one predefined application perspective, which is called all services. This comes once you, let's say, are new to Instana, and you can create your own application perspective. I will show in a moment. And in this all applications, you see a dashboard. This covers all the service calls that are made in this environment. So when I deploy 100 new Kubernetes cluster in this environment, I monitor them in Instana. They will be part of all services. So I see for the top right, for the last 10 minutes, 6,215 calls, 0.03% error rate, 40 milliseconds latency. So all of this is in there. Now, I don't want all of this to be in there because, let me go back to the infrastructure map. I'm just taking care here of this DevOpsConf Kubernetes cluster. So I just want to see traces and application information from this. This is why I go to applications. I create an application perspective. I call this DevOpsConf demo. And here I can specify what criteria should match so that this is part of this application perspective. And here it's super easy. I want to have a specific agent zone, and the agent zone should be DevOpsConf. Add filter, and I'll leave this empty. That's it. Now I have created my application perspective only for all the machines that are in this zone on this carpet. If somebody of you says, okay, but we have a 50-node Kubernetes cluster, I don't really care about this cluster. I'm only taking care of a certain namespace. You can specify namespace there as well. If you say, I don't care about namespaces and I don't really care about all the containers, I just want to have a container with a specific Docker label, you can specify this as well. You can say, whenever I have a Docker container that has a label responsibility equals Peter, then I want to have this in this application perspective. And after a short moment, you will see these are now all the calls that are taking place in this Kubernetes cluster. So pretty easy to deploy, point one. And here you see all these traces. And Instana is doing this automatically. So why are we doing this automatically, or why do we think this is a good idea? Because some of you say we have Prometheus, we have a lot of metrics. Some of you may say we're using Jaeger, Zipkin, something like this, where you have to trace points. We think it's a good idea to do this automatically so that you have context. Because a metric doesn't help you when you do not know the context. A metric without knowing on which component this was collected is useless. And a metric with a value without you specifying or without you knowing is this value good or bad is useless. It's just information. This is why we need to do this automatically. The same is true for tracing. For tracing, you of course get the information, what inbound calls did we have, how many, what was the error rate, what was the latency. But much more important than this is to get an understanding of your application. And here when I click on dependencies, this is how Instana sees the world. What Instana is doing, Instana is checking all these traces, all the inbound and outbound calls. And of course we can measure the response time, the number of calls, if it was an error or not. But what Instana creates by this is an understanding of your application. So in this case, Instana found out that this shipping service here is making calls to a service called, or to a database called cities. And shipping sometimes makes calls to this card service, as you're seeing here. So Instana immediately, as soon as there's one trace, immediately knows which dependencies are there. And this is done automatically. And by doing this, we can identify if this card service here has a problem, this will very probably have an impact on your shipping service. You can try to do this on your own to configure this, but this is really complex. And you've just seen how easy it is to deploy this. So by having this, we get an overview of the entire service dependencies. Let's now go to a specific service. Let's say I'm interested now in this catalog service. What I can do, I can click on this, just left click. I can go to the dashboard where I see all these metrics. I can go to a flow where I see inbound and outbound calls, or I can go to analyze. Let's first go to the dashboard. You see here on the top, you see I'm in the applications view, applications DevOpsConf in this service. And here I only have an overview of all these calls made to the service. And now I want to see what endpoints I have. And endpoints are APIs that this service offers. Here you see these are the different endpoints that we're detecting. If you specify some request path templates, we even group them by these. And I can drill down. For example, I want to see, okay, what's going on with this endpoint. I can click on this. And you see almost the same dashboards. The dashboards we are calling curated dashboards because we don't want you to search for information. We want you to immediately find all the relevant information. When you open an Instana application dashboard, on the top left, it's always the total number of calls. On the top middle, it's the error rate. On the top right, it's the mean latency. And here you can really drill down very deep into the entire service landscape. So let's say now I'm responsible for my DevOps demo application. Again, I'm going back to this. And now I want to have let's say, a view of all the traces, everything that happened in this DevOps demo environment. I can click on Analyze Traces. Then Instana jumps here on the left-hand side from this applications view to Analyze. And it automatically specifies the DevOps demo as an application name because I came from this. You can immediately jump here to this application, to this Analyze functionality and just create all these filters on your own. In this case now, I see the application name and I see everything is grouped by an endpoint name. So now let's take a look. Okay, this has 26 calls. This had 8 milliseconds response time. Let's just take a look at this group. And in this group, I get a list of all these requests. 30 traces is not a lot. Again, it's a very small Kubernetes cluster that I just started to demo this. You see all these individual calls, which service, which timestamp latency. I can order them by latency. And in this latency, I see in the last 10 minutes, the slowest call was this with 38 milliseconds. I can click on this, and then you see a distributed trace of this specific call. And again, this comes automatically without you doing anything. Again, you saw what I've done so far. So you see in distributed trace, and now when I want to get more details about, for example, this one, in this case, the self time, so the time it computed in itself was 1 millisecond. It had 33 milliseconds network transmission time for waiting for others, for communicating to other services. It was waiting 1 millisecond for another service call. And when I click on this, on the right-hand side, I get additional information, including which endpoint, which service, and very relevant, especially in today's times, you get for this specific call the entire stack. So for each and every call that is done in Instana, you immediately know on which stack this has been executed, because this can be a replica set of 20 instances. And then when you want to figure out, okay, what was going on, you really want to know where was this originating. So you have this, and what I can do, I can click on this link, and then I'm at the Kubernetes pod dashboard. Or I click on this link, then I'm at the Docker container. Let me just do this. So there we are. And now Instana is showing me all the relevant information of this Docker container. So Docker image information, the container labels and so on, all these relevant metrics, and again, the entire stack. So whatever view you use in Instana is always related to other components. So we do not just show you a metric or a dashboard that is not related. If we show you a call, we know the entire underlying infrastructure. If we show you infrastructure, we know which part of which Kubernetes cluster this is, and so on. It's all about context here. So let's go back now for a moment. So we have started with the infrastructure deployment, and we went to these applications. Now I've skipped this Kubernetes. What happens is I've just deployed this as a daemon set with the cluster name DevOpsConf. And what you're seeing here, Instana knows it's a Kubernetes cluster. During the demo, initially, we just had this, and now we have this one. No need for configuration, we do this automatically. If I click on this, you get more information about this with all these metrics, all the information, top nodes, so that have the most pods running, top namespaces, top deployments. You see here, and you can drill down in all of these. Let me just give you a few examples. I care about Kubernetes services. So these are all the Kubernetes services with all the relevant information that you need, without the need to move to a different tool to go into your Kubernetes or OpenShift dashboard. It's just all in here. I can open the catalog service here. This is a Kubernetes service. You see all the relevant metrics. And I can even go down to the details to see the spec. And this is the spec that you normally would get with kubectl or kubectl to get this information. Here you get this by just clicking. And again, now some may say, but we have these information in some other tools. In Instana, it's again about context. Instana knows these are the metrics from the Kubernetes cluster. And here, Instana has detected this is an HTTP service. It's called catalog. And when I click on this, Instana shows me the application dashboard of all these catalog services. So you can really jump from this to that and vice versa. Okay, this regarding the deployment of Instana, I think pretty easy and pretty straightforward. Now we have customers that have this infrastructure map, and they have 2,000 machines monitored by Instana in one map. This map looks really, really impressive. Is it useful? In the default view, no. It's just impressive. And then when you ask the customer, okay, what do you want us to skip monitoring? Of course, the customer wants to monitor everything. And when we ask, okay, what do you want to see? Each of you in this room has a different perspective. For example, you say, I want to see a specific namespace, a specific machine, a specific data center. And for most of you, this changes all the time because it depends on the situation. Currently, I know there's an issue in this data center on this, service. Or I'm currently running a JVM migration. I want to have information about this. What Instana has integrated then is Here on the top you can see this, it's called dynamic focus. The first thinking was dynamic focus, marketing thought about some wording for this, doesn't really make sense, but after understanding it really makes sense now, because here you can specify on what you want to focus, what you want to see. Let me give you a very simple example. I'm interested now in this DevOpsConf cluster. So I can say, please show me only entities that run an agent, entities that are in the zone DevOpsConf. No rocket science, now I only have this. Again, if you're running, don't know, on these 3 machines, 500 containers, that doesn't really help you. And now, with this DevOpsConf, I'm responsible for all the Java services running there. I can combine this to say, and show me all the elements that are of a type JVM. There we go. This is in the zone DevOpsConf, and this is everything of the type JVM. So I can just see this. So you can slice and dice this with almost all the application data. And you can even do full text search with this. So with this, you can specify what you want to focus on by doing this. Another thing that you can do is you can change the perspective. So currently, we see a host, and we see in this host, Instana has detected a JVM, and this JVM is running in a Docker container. But many of you may prefer to have in perspective, which is not a host, but a container. And I want to have this container grouped by, for example, a Kubernetes namespace. And there we go. Now you see, in this cluster, there is one Docker container. This one Docker container is running a JVM, and it's in the namespace robot shop. So you can really slice and dice this. Very minor thing, so our engineer said, okay, it's not really worth mentioning. I think it is worth mentioning, because now let's assume I've found an issue with this service. I just double-click on this to open the dashboard. I just double-clicked on this because it's a JVM. There we go. These are the JVM metrics of the last 10 minutes. I could switch to the Docker container or to the machine for the last 10 minutes. And what you're seeing here is, you can see these metrics here on the right-hand side, they are moving. It's the last 10 minutes, and we are in live mode, so the data is updating here. And the data entering here on the right-hand side is 5 seconds old from the live system. So whenever you make a change in production, 5 seconds later, you have feedback what went wrong. A lot of other monitoring tools, they collect the data for 1 minute, create an average, then they transmit this to the backend, and then you have the update. So you need to wait for at least 1 minute until you have feedback. And when you have made a critical change in production, this 1 minute is a very long 1 minute. This is why we say this must be faster. And another thing here, the resolution of this data is 1 second granularity. Now you may say, okay, is this really necessary to have 1 second granularity? Let me give you a simple example. You have a host like this one. You have the CPU usage, and let's take a normal system that has 50% CPU usage. So the machine would have an average of 1 minute of 50%. Let's now assume for 10 seconds you have 100% CPU usage, so peak. For 10 seconds of 1 minute. The average value of this 1 minute would be 58%. So what you would do, you would take a look at this metric to say, oh, CPU usage is 58%. I have plenty of room there. But if you ask your customers that were using these 10 seconds where you had 100% CPU load, they would probably tell you different. This is why we say it's so relevant to have this high resolution of metrics. Now some of you may say, okay, good, we rely on metrics. Metrics is enough. Simple example, you would even have 1 second resolution. But if you have in this 1 second, you have 1,000 calls, then you just have an average value. That doesn't help you. Because if a customer is complaining and you have this only metric, that doesn't help you. So this is why you need these traces of each and every request, because then you know exactly what was the distribution of all these calls in this specific second. Make sense so far? Okay, good. So this is about dynamic focus now. So we've covered deployment. Again, I would love to spend more time on this, but I think not really necessary. It's pretty easy. And I think some of you are already told this. Try this in your own environment. With demos, it's super easy to show this. but it's really interesting when you see this in your environment. And as I'm and my team, we are doing a lot of POCs. I cannot promise you something that is not working later on, because then I would be in trouble. So I encourage you, really try this. So we have deployed this cluster. We have understood all these dependencies. And now what happens now? Instana is checking automatically. By the way, I'm mentioning several times Instana does this. You may recognize we have this small robot. This is called Stan. This is our mascot. The idea is that you have so much information and so much data that you need to have an assistant to make sense of all of this data. And this is Instana, or our mascot Stan. So what happens now? Stan, or our solution, is taking a look at all these services. And it is learning what is normal behavior of these services. So what's the number of calls during 1 second? What's the normal error rate? And what's the normal latency? And if there is some exception to this normal, Instana will automatically detect this. So let's assume your load balancer crashes. A sudden drop in number of requests. This is automatically detected. If for some reason your average latency is increasing, Instana will automatically detect this. Now again, some of you may say, yeah, but we have here our custom rule set, we have metrics for this, and we have specified thresholds. In general, thresholds is not the best idea, because what happens, you have an API that replies in 10 milliseconds. And now where would you specify the threshold? To not wake up your colleagues over the weekend, you would say, 100 milliseconds, it's fine, otherwise it's a problem. But if you have for 12 months all the time 10 milliseconds, and now it goes up to 12 or 30 milliseconds, something is going on. So you probably want to be aware of this. And Instana knows about this, and Instana knows how to adjust these thresholds. And this is what we're doing. So whenever something happens, Instana will automatically tell you that the service has an issue. And because we know all these dependencies, Instana will, again, it's all about context, collect as much context as possible for you to find out what's the root cause of this. And let me show you how this would look like. On the left-hand side here, you have events. And our first-class citizen here is an incident. So an incident is something that we automatically alert on and where service is impacted. Issues, you can say as second-class citizens. In this, you have service issues, as well you have high CPU load or something like this. So you have all of this in issues. What's the reason? Again, a little bit over the top, but if all of your machines in your data centers are running at 100% CPU load, no one should really care about this. This just shows you're using your resources the right way. But if one of your services is getting slower, then you have an issue. And this is the idea. Instana is in this incident view is really focusing on service quality. And here we know at this point in time it has started, it's still active, sudden increase in number of errors on EOM front end. I can click on this, and then on the right hand side, let me just maximize this. You see what has happened. So a sudden increase in number of errors on EOM front end. I can click on this and you see immediately where this has increased. What happens then is Instana is checking all these dependencies, and it has found out EOM front end is using a service called EOM shop. This is using a service catalog. Catalog is serving using an instance catalog. It's using discount service. And when I scroll up, you can see they are using a MySQL database. We know this from tracing because there are JDBC calls to this MySQL database. And Instana knows this MySQL service is offered by a process, MySQLD. And this went offline. So what happened? The root cause has been followed from one service to another, to another, to another, to infrastructure. And in most cases, this here you see took, don't know, 5 seconds. In most cases, this takes, don't know, minutes or hours. Because what happens first? You say EOM front end, let's take a look at the logs or at some metrics. Oh, it's not EOM front end, it's some back end. Oh, it's EOM shop, let's take a look at this. So you would need to jump from one service to another. And once you're here at a service boundary and it comes to infrastructure, then there's in many cases another, let's say, interface or cut where you would need to involve other people. And here it's really easy to find this information. This regarding service quality and what Instana does. By the way, I can just show you how this looks behind the scene. So we are really trying to make Instana as clean and as tidy and as useful or simply useful as possible. And this is what running behind the scenes. We call this the dynamic dependency graph. This is for this very simple demo environment. These are all the elements. So processes, Docker containers, deployments, everything. And these edges, they show that there are dependencies. This is the dynamic graph of this. And in the next second, this can look different. Because now if I kill a pod, and this pod is orchestrated or scheduled on another host, this changes. And no one really can take care of this. And this is the data structure that is running, let's say, below Instana to make this analysis of these dependencies. So now I think we are in a pretty good shape. We have monitored our Kubernetes cluster and we have deep insights into this. We have monitored here our service landscape, and now we understand, okay, what's the performance all of this. By the way, this is indicating here Instana has detected some issues on these, so we are aware of this. And this is not really a guarantee that our customers are happy. Because let's assume, so sometimes I'm joking, I'm from Germany, and in the rural areas, on the outside areas of Germany, internet connectivity is really, really poor. The centers are good, but really rural areas, really poor. So what happens? Somebody is using my services here, running on my Google GKE cluster, scheduled high performance, and perhaps they are not happy with this. To extend Instana's monitoring capabilities to this, we have added website monitoring. So I can click on this. There's a demo website in this. And the only thing for you to monitor this website that you need to do is you have a little bit of JavaScript snippet. Let me show you how this looks like. Looks like this. And this JavaScript snippet is deployed with your website as you do with Google Analytics or something like this. And what happens then is every time one of your users is opening this website, your content is delivered and your scripts are executed, and this performance monitoring script is executed. And here, what you're seeing, you see the number of page loads and for single-page applications, page transitions. You see all the JavaScript errors that hit the browser console. You see the onload time. We are doing some geolocation. You see the top JavaScript errors here with the error message. And by the way, I think this is super powerful. You see the affected users. What may happen is I have a JavaScript error, and this JavaScript error appeared 50,000 times. So I would just jump up to say we need to fix this. What you can do in Instana in this JavaScript, you can specify a parameter how we can identify a user session. So this is how we can group this. If these 50,000 JavaScript errors are just by one user, then at night I just turn around and sleep until the morning, and then I can fix this. So, and this is what we're doing here. You see for the JavaScript errors the number of affected users, so that you can check, do I really need to react on this? All these charts that you're seeing here in Instana, they are live calculated. So for example, when I just want to see all these metrics for Chrome, then you see all this data is updating. So this is lightning fast. You can assume in this demo environment, this is not worth mentioning, but in big custom environments, it's a lot of data that we're processing. And so this is why we have a lot of different data stores that are best fit for the purpose. So you can slice and dice and update this. Let me clear this filter. And again, I can click on Analyze Page Loads. Then I'm back in this Analyze functionality of Instana. I see all the page loads for this website grouped by the beacon location path. I can click on this, and then I see all the page loads. And again, we are not sampling. Instana has all the data. If somebody has accessed your website and has executed this JavaScript, then you have this page load for this user. I can open this just by clicking on this, and then you see relevant information, point in time when this has been executed, the JavaScript error number, count, number of resources being loaded, images, JavaScript, and so on, async HTTP requests, which website this was part of. You get information about the user. This especially when I show this in Germany, a lot of people are smiling because you usually don't have usernames and something like this in it. You can, so in this JavaScript snippet that I've just shown you, you can add a method to say, I want to tell Instana regarding the username or email address. So you could do. Most of the customers that I'm working with, they don't do this. What they are doing is they just generate a random number and they put it in the footer. And what happens, then you have this random number here. And when somebody's complaining at support to say, I've used your service and this really sucked, they can say, just scroll down, you see this number, send it to us, then we can analyze this. With this number, the user can be, or the session can be identified, and then they can analyze. You get information about, relevant information about the browser. We are doing geolocation. You can add meta information, again using this JavaScript. As an example, membership, gold, or which environment was this. And then if I scroll down, you see all this information that you probably know from your browser developer tools. So all the resources that have been loaded, when they have been loaded, how long it took to retrieve them, and you have all of this data for each and every request. Again, a lot of data. So here, image has been loaded, you can click on this, and then you get additional information, so encoded body size and all of this for each site load. Because we want to make it easy for you to find the root cause. If a customer or your boss or whoever is complaining, standing behind you and say, guys, I used our service, we really have an issue, that you immediately know what is going on. And as we are not just running on your end user's browsers there, but in the backend as well, we have this button here, View Backend Trace. And what we're doing is we combine this. So on the top, you can see now end user information, so who requested information from the backend. And on the bottom, you can see these are all the backend calls. This is a distributed trace of the backend that was executed to deliver this content. So now we merge this. And again, this goes down to a single database statement. So we've extended this to website monitoring. And now you may say, okay, Peter, you mentioned application performance management or monitoring. This is application, but we don't have, or we have not seen code yet. Here on the right-hand side, you see the caller stack trace. This is for this database call, all the methods that have been executed with all the classes. What I can do, I can click on this class, and this, now Instana, the backend tells the Instana agent to upload the class file. And now you can see which code is deployed in production. We have this feature for a long time, and to be honest, I was not really sure if this was a good feature or not. And then I went to a customer, and we took a look at the trace, and we had something like this. And here we had 350 database calls. And I said, okay, I cannot judge if this is good or bad, but 350 database calls, the same table, the same database, perhaps has some room for improvement. And then the customer said, Peter, we already improved this yesterday. I said, but this is a trace from now, so probably not. And then we took a look at this, and the customer identifies, oh, it's different code that is being executed, and he found out that his deployment pipeline was broken. So he committed this, he expected this to being deployed in production, it was not. And with this case, you can really very easily find this. So this regarding this functionality. And now we have all of this data, and when you're familiar with Instana, it may happen that you want to have a specific look at this data. As you have seen, Instana has a lot of data that you can analyze. And when I click here on Analyze, then you are in this Analyze view. Here on the top, you can specify what you want to see. A trace is an end-to-end call. Sorry, a trace would be service A calling service B, calling service C. The trace would be named service A, and all these subcodes would be grouped under the trace. When you click on calls, you have calls for service A, calls for service B, calls for service C. And here you have all this end-user monitoring data. So let's now assume I want to have an overview of the slowest database calls. I can select calls. Now I specify by type. I want to see only database calls. The database calls are now automatically grouped by the endpoint name. For a database, the endpoint is the table. So now I can see this table here had the highest number of calls, took less than 1 millisecond, and 0% error rate. These are all the calls of the entire environment, not only my DevOps cluster, but the entire environment. Or I can say I want to see all my database calls, but not grouped by an endpoint name, but by a database statement. So now I can say I want to have it grouped by call database statement. Save. Now I see that this statement here has been executed 2,204 times in the last 10 minutes. It was fast, but executed a lot of times. And now when I would show this to you, you would say, probably, in which context? And in Instana, it's easy. You just click on this, and then you see all of the individual requests. And when you want to, take a look at a specific instance, you just click on this, and then you see the part of the distributed trace where this statement was part of. So with a few clicks, you can really slice and dice and go down to this layer. Can you still follow me? So it's, okay, good. So it's really about having access to a lot of data and this very, very fast. Now let me give you for this analyze a different kind of analysis. Because what I told you earlier, we have all these individual application calls, and we know the entire application stack where this has been executed. Now what I can do, I can say, please show me all the call types that are of call HTTP. And do not group them by endpoint name, but group them by JVM version. Sounds a little bit confusing, but now I see all the HTTP calls grouped by the JVM version. And now I can compare, okay, I can even select here a specific service. And if I have a service deployed on Java 8, another service deployed on Java 11, I can compare these traces to see what's the error rate, what's the response time, and so on. So you can do this. And now this would be interesting to see how this here changed over time. This is the last 10 minutes. Let's say we want to see the last 1 hour. There we go. And now you see here this small button called Show Graph. I can click on this. It shows me the number of calls, again distributed over time, and I can have the latency. And this is now the latency of my services, and I can immediately see where this increased, for what reason ever. Again, this should just give you an impression. Let's say I want to have HTTP calls that were slower than 10 milliseconds only, safe. And I want to have HTTP calls slower than 10 milliseconds, more, running with a specific Docker label. And where the Docker label, here you have all these Docker labels, container name, and here you have a suggest. So you can really slice and dice across the entire Slack with this. This is super powerful to find the relevant data for you. Sure. Very, very good question. So, synthetic in this case is, let's go, probably some of you are running Spring Boot. Who's running Spring Boot? Okay. In Spring Boot, you have all these health checks that are called all the time. Let's say you have, every second you have a health check. And you have a service that is called once a minute. And when your boss asks you, how many times has this call been, or this service been called in the last 1 minute? 61 would be the wrong answer because it's 60 health checks. And this is how we can, on the one hand, automatically detect these health checks. We call them synthetic, like Spring Boot, like some actuator endpoints and so on. And if we do not detect them automatically, you could configure them. And these are these synthetic calls. So we are collecting them. We still have them in tracing because sometimes you want to see them. And when you enable this, you can see them. This is synthetic. Okay, so further questions? Yes. Currently, what you can do is, so we have different areas of this alerting. So first, in the tool itself, Instana comes with a little bit more than 200 built-in rules Some of you probably you would add, but some of these rules are really useful. For example, JVM garbage collection activity. We come with these rules, and a lot of customers don't really care about this, and then they find out, oh, I really have an issue there. So, and these built-in rules that we deliver can be disabled or deleted, and in the some tuning. Okay, so yeah. Currently, you cannot. What you can do, this built-in rules, you can disable, and you can create your own rules. So what we have done, so now there may be a little bit of confusion, why can't we? Because we have this built-in rules in Instana for a long time, and what we did in the last release, we brought this into a structure that we can make this UI-facing. There needed to be some adjustment. Now it's UI-facing, I can just show you how this looks like. And now you can, there you see events. So that's, don't know, sudden increase. Sudden increase or sudden drop, something like this. So sudden increase, you mentioned sudden increase in number of time, sudden increase in average response time. Here you see, this is the rule. This is a short description, and here is how this is being calculated. So we have a description of all these metrics, and here the values. We have this in the tool, and the next step is that you can change these values. But first, we need to put this in the UI. It's on the roadmap. Will come on short notice. So then you can adjust this. What you can do, even today, you can add your own events. You can say, for example, it's interesting that Instana learns about this, but we have an SLA. So whatever Instana learns, we want to notify it when it's above 100 milliseconds. You can add this as a rule. And you can add this using the user interface, and everything that I've shown you so far is accessible using an API. So no need to use the UI. Yes? Mm-hmm. So what we do is, this points me to, I have not completed my previous answer. So this is about alerting. And what you can do is, for example, when you say, I do some maintenance on a cluster, then you do not want to have this alerting. For this, you can create maintenance windows here, and you can specify with this dynamic focus that I've shown you so far. Currently, I'm doing maintenance on all the Docker containers having a specific label on this cluster. With this, and with alerts, you can specify. So let's just go through this very quickly. Here you have alert channels. And alert channels, this is what we deliver out of the box. Email, because we have to, so that you can create rules to put this into your trash. Just kidding. So email was the first legacy. Slack and MetaMost, Ops, Genie, and PagerDuty, we have integrations. You just specify your API key. That's it. We push this to them. Office 365 Teams, Splunk, Google Chat, VictorOps. And if this is not enough, you can specify as many web hooks as you want. Then we just push a JSON data structure to this URL, HTTP or HTTPS, and then you can work with this. Let's now take an email alert. Let's say Peter, and it's Peter at localhost, no, Peter at peter.de. Don't know who owns this. Let's not check this. Now I have this alert channel. And here with this alerting configuration, I can really slice and dice what information Peter should receive. So first, I can give it a name, again, demo. And then I can specify which kind of event. I can pick individual events. For example, if an SLA for this service is not met, then alert Peter. Or you can say Peter should get specific event types. So all the incidents and critical issues. And here on the bottom, you can specify the scope. I can say an application perspective, what I've shown you earlier. Or you can specify these entities with this dynamic focus that I've shown you. Entity zone, entity tag, and so on. And then you can say, okay, these kind of alerts I want to send to Peter. So you can really slice and dice this, very powerful. Giving you another example how powerful this is. We have a lot of customers that are using Kubernetes OpenShift, and they specify Docker labels who should be notified. And with this rule set, you can say, whenever there's a critical or warning issue in a service that runs in a Docker container that has the label responsibility Peter, then send this to Peter. So you just create this once in Instana, and then everybody configures this in Kubernetes or OpenShift. There's no need to touch Instana again. Yes? Absolutely. And this is our even preferred way here. So this is our open API documentation, and everything that I've shown you so far can be configured using an API. If you want to have, let's say, you just deploy a new cluster and you want to have an application perspective, API call. When you want to have a specific event for these services, API call. Just upload this, make these API calls, and that's fine. You can create, what do you want to export? The configuration. Configurations you can export. You could even export metrics and traces. But when this, some customers asking, can we export this? Then we always ask, okay, why do we want to export this? Because probably then we should extend our product. And as you can see, it's a lot of data. But all of this is open API. You can export this, you can import data, and so on, and configuration. Yeah. Yeah, super easy. You just export the configuration, you push it to the new instance, that's it. Yes. Yeah. Yeah. So the question was if you can add meta information to Instana. The answer is yes, to traces. So what you can do, I think the easiest way to do this, when you have HTTP calls, for example, Instana, you just configure the agent to collect HTTP headers. So we just take this header, just put the header name there, and then Instana will automatically collect this. And then when you go to, an application, so to a trace, what would happen is, just a short second, there we go. Okay. What you would see here, sorry for that, on the right-hand side, here you would have another field with this HTTP header. And what I've shown you, selection, so filtering and grouping, can be done by this. If you want to have this, you want to extend this further, we have for most of the runtimes SDKs. So you can just say, for example, in Java, I want to have this method being traced with all the meta information. You put a runtime annotation there, and then we have an SDK for this. And before jumping into this, because we talked about API, many customers said we want to have APIs because we like dashboards. Instana's nice, but we want to have a dashboard. We collected feedback from customers. What do we want to have? They said we want to have traffic lights, green, yellow, red. So what we did, over there are the Grafana guys. Very great tool for custom dashboarding. The only thing that you need to do is you specify a data source. There's an official data source for Grafana to Instana. The only thing that you need to configure is your backend URL and an API token, and that's it. Now I have full access to all the metrics that Instana has. For local, yes, it's the same for local installations. Now let's say I want to have a query. There's the query. I want to have infrastructure metrics, and now I'm interested in everything that is running in the zone DevOpsConf. We just deployed this. Sorry, it's the wrong data source. So DevOpsConf. And now Instana said, for this, Instana told Grafana, 2 minutes, okay. Now Instana told, okay, in this cluster you have these components. For what do you want to have metrics? Now I say I want to have Docker container metrics, and for Docker containers I want to see the CPU usage. And this is now, because we started just from here, you have all these metrics now. And this is, we didn't want to reinvent the wheel, because Grafana is great for this, and this is why we just connected this. And the big benefit for you is the data stays in Instana. You don't want to have this data stored twice, or 3 times, sorry. Absolutely. So the question was, can we exclude some sensitive data? So Instana itself is really collecting only information that is relevant for you to find performance issues. If we found out that our customers are very creative in putting sensitive information in some tools, for example, you see, don't know, Java startup parameters then contain a password. If the parameter is called password, we just ignore it because it's obvious. And if you say you have your customer name equals something and you don't want Instana to have this, you can configure the Instana agent, it's called secrets, to skip this information. So when the Instana agent detects this, this is automatically dropped and not transmitted to the backend. You can do this. Further questions? No questions? One? Oh, sorry. No questions? We are over there at the booth at Product Security, so looking forward to seeing you there if you have questions. Sorry.